All right, we'll get started. I'm Scott Carpenter. I'm a third-year PhD student in Bill Lauenroth's lab and a member of the BIOMES committee. BIOMES is bridging issues and optimizing methods in environmental science. So BIOMES is YSE's flagship seminar series, and the intention is to bring cutting-edge research and new ideas to the YSE community. It's a community source series, and we're always accepting suggestions for future speakers, either by submitting them through the Google form. You can see the QR code here and scan that, or by emailing biomes.yse@yale.edu. This spring, we'll be focusing on EJ as our theme. So you'll see that when you look at the form, it'll kind of give you a brief description of speakers that we're looking for. Today, we're very excited to be hosting Marian Chertow, giving her talk, and there will be a short Q&A following the seminar. Since we're over Zoom, you can either submit through the Q&A box at the bottom, or when we hit the Q&A, feel free to use the raise hand function, and Professor Estes will call on you, and you'll be unmuted to ask your question live. So I'm gonna say thanks for listening to me and turn it over to Dan Estes, who's introducing Marian.
Scott, thank you very much, and thank you all for joining our conversation today. Again, I'm Dan Estes, professor in both the Environment School and the Law School, and director of the Yale Center for Environmental Law and Policy. It's really a great pleasure to introduce to you all our speaker today, Marian Chertow, who's been my colleague on the Yale School of the Environment Ladder faculty since 2002. She also has appointments at the Yale School of Management and with the National University of Singapore. Marian brings to the conversation today a global reputation for her work in industrial ecology and in the circular economy, particularly on the issue of industrial symbiosis that she's going to explain to us today, but also her broader work on environmental technology commercialization and the issue of waste management and how to overcome some of the challenges of really getting to a significant degree of recycling. And by the way, I might just say she did an outstanding chapter on how the future of waste might unfold in the book that the Yale School of the Environment developed and produced over the last couple of years called A Better Planet, 40 Big Ideas for a Sustainable Future. She is more broadly a teacher and a researcher on corporate environmental management and has made significant contributions in that arena as well. She's the author of more than 70 peer-reviewed journal articles, and she has a recent edited volume out from Oxford University Press on the science, technology, and innovation elements necessary to deliver on the UN Sustainable Development Goals. She's been the president of the International Society of Industrial Ecology, a field, by the way, that she really helped to build and create. And she has also won the Society's annual prize for outstanding contributions to the field. She has a number of other engagements beyond Yale and service to the issues of industrial ecology, including service on the Canadian Circular Economy Panel. She has also been inducted into Connecticut's Women's Hall of Fame. And I might just give you one last thought before closing out, and that is that Marian brings to her focus on waste real hands-on experience in that her first job out of college was working for a MRF, which those of you in the waste world will know is a materials recovery facility. So her expertise is really from the ground up, or maybe I should say from the inside out. With that, I give you Marian Chertow and her topic today, increasing business efficiency in community through industrial symbiosis. Over to you, Marian.
Hey, there I am. Well, thank you very much, Dan, for that wonderful opening. And I'm so excited to be able to share the things that I am so interested in with research to the group today. So you see our complex slide. I've embedded the fact that we have the Center for Industrial Ecology and put into that my interest in industrial symbiosis, which is a subfield. So those are really our topics for today. It's true that we've been with industrial ecology almost since the beginning. So we've had a very interesting way to observe how a field takes shape, how the research develops, and those are a couple of my other themes today. I'm going to start with industrial ecology because I'm very proud that Yale has made such a strong commitment to industrial ecology. I'm the third director, so we've had our center since 1997, and the field really didn't get started until the early 90s, so we are also early in. Many of you know our first director, Professor Emeritus Tom Gradle, and Tom was full of firsts. He was the first industrial ecology professor. He was admitted to the National Academy of Engineering, owing to his contributions and helping to create industrial ecology. And he left the Bell Labs to come to Yale so that he would be able to teach industrial ecology. So we have a great background, and we've had lots of great activities in the center. We have about 20 people there. So there's lots of industrial ecology going on at YSE. First, I want to share for the people who don't know what is industrial ecology, what's some background. And so you see that the emergence was in the 90s, as I've said. We've always been a multidisciplinary field, and these are some of the sorts of people who join us: environmental and social scientists, engineers, business people, policy people. And so this richness has always enabled us to find the person that might be able to answer the question that would create a new solution. The field is very much involved with a focus on physical flows and stocks of materials, energy, water through systems at different scales, from a single factory to a city, to a state, to a country, and finally to the globe. We are always tracking these materials. But beyond that, we don't stop. We don't just be a bunch of accountants, but we also examine how can we remove barriers so that we can reduce waste and make things more efficiently. And that's where we bring in the economic and political and regulatory social factors that you see in the third bullet of this slide, said by Robert White, who himself was the chair of the National, excuse me, I'm messing that up, the National Academy of Engineers. He was president when industrial ecology was being born. We've had a lot of strong institutional support around the world. These are some of the universities that are so actively engaged in industrial ecology that we consider our peers. A lot of you know about NTNU, the Norwegian Technological University, because Edgar Hartwich was our second director. Tsinghua University in China has been a very steady partner in industrial ecology, and they hosted the most recent International Society for Industrial Ecology biennial meeting, which was just great. Leiden in the Netherlands has a standout, lots and lots of faculty in industrial ecology. And finally, our own organization, International Society for Industrial Ecology. So some more background. But what I want to share today is that some of you have watched us try to grow this industrial ecology thing for many years. There have been some really important changes. And I think the most significant change is in the increasing sophistication and the utility of our tools. I'm not going to go through all of these tools right now. You know, you've heard of them: material flow analysis, life cycle assessment. What I want to say is that even life cycle assessment is so institutionalized, it's already has its 3 ISO standards. We've just been able to push these fields along so that they were more reliable, more consistent, and most importantly, these 4 tools and approaches are what we teach in the industrial ecology class, in the survey class. So these tools have come along, and we're very proud to share that progress. But even though we like this progress, we recognize that industrial ecology is still not a household word. So as confident as we are about our tools, we know there's still a communication gap. And so we actually took this on this year, the better part of a year, to say, how can we approach this? How can we get over this communications issue? And the decision was made. I must say that the Yale members were very, very participatory in this, to create a new tagline for our society. So today, right now, you can go to our homepage and this is what you'll find: International Society for Industrial Ecology, Science for Sustainability and Circular Economy. And we did this again for communications reasons, because people kind of know what circular economy is these days in the environmental sphere. Lots and lots more people know what sustainability is. And so this is our identifier now. And I have to say, from an organizational perspective, we had votes on this, we had chats on this, we had two annual meetings about this. And this was what we decided, it got the most votes. So for some reason, this issue really engaged so many of our members. And we hope that this tagline will help to bring in more members. We're already at record heights now for members. So these are all ways that we're trying to open up a little bit more and find that good home. So moving right along, I just think there's probably a few more things to know about your speaker, although Dan was very generous in saying many of them. And I usually say for myself that I'm primarily engaged with industrial ecology and symbiosis, but waste management, circular economy, business and environment, I'm the co-coordinator for our specialization in that. You know, these are the other things that I do. Using industrial ecology tools, I've looked also and written about urban sustainability, the Sustainable Development Goals and how they can help industrial ecology, and also the metabolism of islands. Islands turn out to be a great study area for us, just the way they were almost with Darwin. You know, that there's boundaries, that we can track material and energy flows, we can get around to people on the island, we can figure out how much it costs at the extremes to be able to have to transact monetary exchanges with islands. All very interesting. And so it's another reason why we've taken a lot of our students over the years to Puerto Rico, to Hawaii, and to other islands, because we get this extra boost in the research where we can get the numbers and find those boundaries. So these are a few of the grants that we've had just in the last, since 2018. Again, I won't go through them all, but I do want to mention on the left-hand side that we've been working on non-hazardous industrial waste for several years now. This is just as it sounds, you know, waste from industries, whether they're pulp and paper mills, or whether they're from agricultural waste. But this non-hazardous industrial waste, we always assume will be the most symbiotic. And so that's the tie-in of why we constantly study this non-hazardous industrial waste. We've done a lot of work on it industry by industry, and also collectively. Now we're doing a lot of geocentric work for figuring out how we can regather the non-hazardous industrial waste for reuse. We have an exciting grant about robots and the division of labor between robots and humans. At the bottom of the slide, you see a photo of people trying to pick out the right recyclables on the conveyor belt. And this has been fascinating. Most of the PIs on our grant are roboticists. Barbara Reck from the Center for Industrial Ecology and myself, we're the two garbologists. And it's been very eye-opening to try to figure out how, when a new technology like this comes in, what does it do best and what doesn't it do, and what happens to the people? So we're actually in the future of work section of the NSF on this one. We're also working on Remade Institute, funded by DOE. This is a really interesting national effort to make our recycling industries more competitive. And so we're working on this, doing a lot of modeling with our colleagues at Santa Barbara to try to figure out how we can improve the technologies and improve capacity at a reasonable rate in the near future. So we've done a lot of work in China and India all across the board. The Macmillan Center was kind enough to help let us study reuse of apparel in Rwanda. And Pratt and Whitney, we've worked with, again, for many years. They really like to support doctoral students and this and that. So this has been a great relationship. And finally, the last one on the right says that we've been looking at the sharing economy. What we really looked at was food waste, and would somebody who only ate half their sandwich be willing to share that with the next person? And there's a whole network now, a whole app on this globally, and it's working pretty well. We have a pretty significant article on this in the literature already. So why industrial symbiosis? Why does it make my heart beat? What's so exciting about it? And if you've ever heard of an industrial symbiosis cluster, you've heard about the one in Denmark, in Kalundborg, Denmark. I just have to say that I found this eye-popping the first time I saw it in the 90s. I just thought, wow, in 1973, in this small city in Denmark, there started to be some industry. And by 1996, look how dense it's going. There's so many different kinds of industries. There's a power station, and there's a fish farm, and Novo Nordisk is an important pharmaceutical company. And each arrow you see means that they're sharing in one company's residual becomes another company's feedstock. And that's what you're seeing in 2012, even more concentrated. A lot of attention, I'm circling it now. Can you see me circle? Probably not. About water and pooling water, and how substantially they've been able to reduce the water load by 40%. So it seems like this is something very innovative, very exciting. My career, as Dan said, goes back to my college days. And when you're interested in waste and politics, and you see something like this, you go, wow, this is something new, and we've really got to push it. And so that's what happened to me. Happy to be here. When you look up at the top boxes, we talk about business, because industrial symbiosis primarily occurs across businesses, place-based in industrial ecosystems. Those are the words we use, industrial ecosystems. And what I love about it is, in recycling, you throw the thing away, then you try to recover it, then you try to make it worth value, but it's hard. But these byproducts are cycled without ever becoming waste. And so that, for me, is such a good goal. And as you see in the Danish example, you can create a system that evolves and sustains. I mean, right now, if I showed you the diagrams, and we won't have time for that, but they look completely different. They have had such a rebirth of lots more companies that want to come in, and they've gone private. We're trying to understand the life cycle of these clusters. And in 2014, they started to rethink, and it's to us very fascinating. They're about to celebrate their 50th year of existence and change. So a good time to be gathering data, I'd say. On the community side, and especially in Kalundborg, the big word is the Rotary Club. It turns out that a lot of the business people in the small city belong to the Rotary Club, and this form of community has really made this work, that the community has been so dedicated and has such good interrelationships and have a certain amount of social capital. So the Rotary Club is important. The soccer teams of the children of the managers are important. And the reduction of friction when people know each other, are willing to be more trusting. This has been an outstanding characteristic of this. And everyone in every cluster tells us that the trust is a very significant part. So here's a formal definition by me from the year 2000, and it was published in the Annual Review of Energy and Environment. It's gotten a lot of visibility, and basically what I want to remind you about is that we're engaging traditionally separate industries, right? So it's not like everyone in the cluster is oil and gas, but it's this arrangement of so many different types of businesses. And taking a collective approach. That's difficult in business. And it's very interesting that this has been successful. I threw into the definition competitive advantage because I wanted it to be taken as a as a business principle, right? That we can make a collective approach to competitive advantage. And what it's about, as I've said over and over already, is materials, energy, water, and byproducts. So the keys are collaboration, and I want to say for geographic proximity, many parts of it are geographically proximate, but sometimes the materials that are recovered in symbiosis to find a market go further away. So I probably didn't mention this, but let's do it anyway. I'm about to hit 2,000 citations on this article, and I'm not bragging. I'm not even good at selling myself. What astonishes me is how surprised I am that this many people in a small field would want to read this article, and it's kind of considered the seminal article in industrial symbiosis. So I want to describe, since we have this unique picture of being there from the start, how we have advanced the understanding of industrial symbiosis. And so I've sort of organized the rest of the talk around these research dimensions. The first is exploration. How do you understand? Is this a new field? Is it copying an old field? What experiences do we have with actual clusters? So there's always that presence of academic and practice, which is key to industrial symbiosis, and assembling the people. So that's the first part, is the exploration. The second part is the progressive synthesis, that we understand more deeply influences and phenomena over time. And what I mean by progressive is that we return to some of these themes even years later, because we now can synthesize the ideas and understand and explain more deeply how industrial symbiosis is developing. Another dimension are contributions, and we're calling this substantive knowledge and discourse, right? And that adds something particular to an academic field. That's our definition, and that's what we've been working with. And finally, impact. How can we think about our impact in the world beyond academia, but having our scholarship be able to point and say, we influenced these practices, and now that someone's out there actually taking tangible actions for society. So the exploration stage is interesting. We do find that there are similarities and borrowings with other types of fields and domains. So, for example, ecology, you can see the picture of the bee and the flower. The ecology suggests that we do borrow quite a lot, and of course we've borrowed the metaphor of mutualistic symbiosis. We studied agglomeration economies a lot, because both industrial symbiosis and agglomeration economies derive their benefits from location, from spontaneous location. And so that's very interesting to have a similar root, although the focus is a little bit different. And I don't have time to go through all of these, but let's look at urban development. Industrial symbiosis occurs in cities, but you know what? It doesn't privilege cities, because a lot of times, and we've made maps about this, the real industrial symbiosis is taking part at the city edge, or even beyond, because you need the space, you need to find the industry and so forth. So we tried very hard to dig out what we thought would be useful, and over the years, we've certainly had a great chance to look at these allied concepts and literatures. So we're still in the exploration stage, and one thing we needed to do was to start to bring people together. So both of these events happened in 2004. This was a wonderful meeting that we had at Tsinghua University, when we were all just trying to develop some roots in industrial ecology. And what we did was we had 50 professors from different universities in China come together And Tsinghua and Yale got together and said, let's have a workshop on how to do education in industrial ecology. It was a fascinating meeting. Although these are all women, these are women who came to it. There were men, but I love this picture. And we also did we had a Chinese professor and me do pieces on industrial symbiosis as well, again, to launch and to get it started. We had a grant from the Luce Foundation, $1 million to try to jumpstart industrial ecology in Asia. On the right-hand side, we also needed to get professors together who were already doing industrial symbiosis. And we created this new institution, the Industrial Symbiosis Research Symposium. And the first one in 2004 was held at Yale. It was terrific. There were so many people from so many countries, not so many people, but from the industrial symbiosis world. And we've been able to continue that just about every year. And I'll show you that a little bit later. So for progressive synthesis, I have 4 stories. Want to make sure that we'll have time for everything. But the first one is about quantifying benefits. In a first stage, we were able to look at this aspect of, let's show people how much money they're saving, how much revenue they can gain by making less waste and turning it instead into sustainable products. And so I'm going to say a few more words about that. Self-organization and complexity theory has been kind of one of my main things. You see there that I've written a lot of articles on this because we want to understand how do people get together for industrial symbiosis. There are some business and economic issues. And finally, what we call industrial symbiosis potential. So the first story is about in the beginning, when we had this article in 2005, that was when we started trying to quantify benefits in a cluster, in a small cluster, so that we could show again the meaning and the savings that come in through industrial symbiosis. What we eventually got to in the third diagram is a full life cycle analysis. So showing the progressive synthesis over time. And in the middle, we have the state of Pennsylvania, where they actually work material by material. So we can say, there's recycled paper and there's paper. We want to look at recycled paper. And part of the life cycle experience is to calculate for each one the various parameters, and in this case of substitutions. So if we substitute recycled paper for regular old paper, then you can see that from the perspective of primary energy, the top line, CO2 equivalent, SO2, and NOx, we can see that the substitutions tend to look better on the pollution issues because there are already embedded materials and energy in used materials. We don't have to go all the way back to extraction and so forth. And this is ways that we can use industrial ecology tools to express this. This is another park in Hawaii. Again, the island part helps a lot. And what you see here is the heart of it is a power plant. And then a lot of industries grew up around it. So it's sort of self-organized. And what these sketchy boxes are asks the question, what would happen to byproducts if they didn't have symbiosis? So what if Unitech, a tire recycler, couldn't recycle right in Honolulu? Well, they'd have to send it off island. They'd have to reprocess the oil somehow that's recovered from the rubber. And we can see that it would be likely very expensive. And of course, we've calculated how expensive and how much more pollution would happen when we had to take things offshore. So again, it's that island case. So what I want to really emphasize here is that if there was no symbiosis, the fly ash would have to go to the sanitary landfill. There is a monofill in the sanitary landfill. The sewage sludge would have to go to the landfill too. Water would have to be discharged into the ocean. And so as we looked at this, we saw that that for life cycle purposes, the industrial symbiosis has been very successful. So I'm thinking about the self-organization and complexity. What we really find in the majority of these clusters are that there is not a government voice or even an organized, coordinated corporate voice to say, let's do industrial symbiosis. What we really see is an emergence phenomenon. So firms just need materials and they go to their neighbors and they find some of these materials and they exchange wastewater materials because of economic efficiency reasons. You know, it's cheaper for me to take my sludge from my power plant and sell it to a wallboard plant than it is to try to have to send it away or import raw materials from Spain in the case of gypsum. And so what you see is this quietly beneath the radar emergence. And then I've characterized this as uncovering. Something happens that make the networks become known. And in Kallenberg's case, someone from the Financial Times heard about all these things going on in Kallenberg back in the late 80s and said, I'm going to go there. And of course, by writing about it, people heard about it. And it was no longer just the quiet sub rosa phenomenon, but now we're already into consciously revealing and now being able to act on. There are economic benefits. What are the environmental benefits? And eventually some of this gets embedded and institutionalized. Companies realize, gee, I can save a lot of water doing it the way that other companies are doing it. Let's act more together. Let's have the actors be able to have more longevity and become better established so that these practices can be shared. So this is an example from India of uncovering industrial symbiosis. We went to an industrial park with about 60 companies, and my students, I must say, with methodical care, talked to every single plant manager and put together this chart. And the managers were just astonished. Really, my sugarcane refinery is also getting the byproducts of compost and molasses and so forth. All of these things are connected. And when we actually sat down and showed this diagram, the managers were like, oh, that's mine, that's my product. And people were very proud. And the biggest takeaway from that meeting was that how can we do more? You know, so very interesting. For me, this is the best academic result we've ever gotten. There were about 1 million tons of waste coming out of those 50 companies. About 10 of them we had to exclude because they were too small. And some of the waste materials were used within facilities. So this sugarcane factory was able to use sugarcane and burn it for energy, make their own energy. But there was also a lot of interfirm symbiosis, and that's what you see in this picture. And when you add those two things up, 99.5% of the residuals out of that million were being reused or recycled at least once. So I can't help but feeling that India and many places in India already have a circular economy, and we just hope that they won't lose them. So another key aspect here is this paper on that answers the question, how can we compare all these different projects? Now we know all over the world where so many industrial clusters are that are doing symbiosis, but what can we do to create understanding of cultural issues and other dynamics? So what you see here is a paper called Industrial Symbiosis Dynamics and the Problem of Equivalence, proposal for a comparative framework. And if I had time to explain a lot of the article, we could really talk about how we're doing those comparisons now. But this has some important words on it, that understanding industrial symbiosis as a process of connecting flows among industrial actors. That the problem of equivalence makes one context that's very different from another context, sometimes something where we don't even recognize that both are doing industrial symbiosis. And finally, although I've emphasized the self-organized principle that companies that, like you saw in Hawaii, like you saw in India, come together because it's a practical thing, there are other ways that besides self-organization that comes together as well. So let's take a look at that. At the top, you see self-organization. That's our first dynamic. But other dynamics are mapped differently. So you see on the right that we've tried to map these in our kind of code of what are the steps of these 6 dynamics: the facilitation, the government planning model, not a self-organization like Kallenberg, but planning from the top, as we've seen with a lot of the Chinese parks. And so we've now developed this sort of language where we can talk about all the dynamics at once. And that has been extremely helpful. Lots of people have picked this up and tried to fit their clusters into these categories. And that, again, improves understanding over time. So I'll say a few business things. Another project that I wanted to show you was British Sugar. This is the major sugar beet refining company in the UK. And they produce more than 1 million tons of sugar per year. Now, what happened, if we go back to look at our other forms of doing industrial symbiosis, this one is part of organizational boundary change. And what I mean is, this used to be a company that made sugar, and they had a couple byproducts like stones and topsoil, as you see in the front. And then over time, a lot of entrepreneurs came in and said, you know, we think we could make something in the back and use CO2 from your energy to grow tomatoes, or we think we can take the resin separation process and extract the betaine, which is an important agricultural company. And before you know it, this wasn't just a sugar company, but it has so many of the byproducts. So what I want to say is that there are lots of different types of sugar that are produced, but look at all these co-products that are coming out of their residue streams. So animal feed, I mentioned the betaine, 6,000 tons, the CO2 and so forth. It seems like almost everything is being used symbiotically in British Sugar. And here's the financial part that I wanted to stress also, since this is also a business enterprise. If you look at the lower gray box, that's the sugar revenue. If you look at the dark gray or black box, these are what have been calculated as the value of the co-products that you have on the right-hand side. So look at that. Sugar is an interesting thing. It's regulated in a lot of the world. The prices go up and down, but the co-products or byproducts actually make a kind of a hedge for the company, because there's always this other revenue stream they can rely on at times when sugar is not as profitable. So this is a good example of the financial side. You know, industrial symbiosis also has its share of barriers, and some economists say, well, maybe the transaction costs of setting up these symbioses are just too high. And sure enough, these search costs are very germane to industrial symbiosis. The costs of locating information about opportunities for exchange, the search costs. Now, search costs are standard for transaction costs, but in industrial symbiosis, it means who are you going to find who can take your type of waste? If it's steam, what temperature does it have to be at, and when does it have to be delivered? And so these all have to be negotiated. The second transaction cost, a contract has to be enforced at the end of it. And of course, because there are many counterparties, there are many parties that are involved in the groups, then there too, there can be the cost of delay. So yes, we think the transaction costs are an important phenomenon and in industrial symbiosis. One of our first doctoral students, Shihan, who was from Tsinghua University, had been writing his dissertation on transaction costs and trying to quantify them in different ways. Another thing I feel obligated to say is that why don't we see more industrial symbiosis? It reduces your costs, it increases your revenues, it provides more supply for raw materials. Why hasn't it reached its market potential? Why isn't it so attractive, or why doesn't it look profitable to everybody else? And how could this be reversed? So this is another thing that we've been able to do over the years, is really experiment. You know, in this case, we wanted to try out some ideas we'd never used before to try to explain the inefficiency. And that is from financial theory and the theory of market intermediation, and how can we apply these that seem very useful in many other domains to industrial symbiosis. So here you see it, that we have to understand the product, and the product isn't a product. It's not a primary product, it's a byproduct by definition. That's why it's being symbiosed. And the product focus is sometimes overlooked. People just want to get their primary product out. They don't really care about the waste parts. And that opens up, that kind of makes a hole in the market, right? These are often informally organized markets. There are information gaps, and so someone else can rush in. And with the theory of intermediation, we can see that if there really are price saving, cost saving activities, an intermediary, think of a broker, could come in now and try to organize this in a different way. And so we've tried to follow the lines on the brokerages and recognize that sometimes the broker part doesn't work, the intermediary part doesn't work, because the owners of the products are saying, well, if you can do it, I can do it, I can sell it. And of course, that's known as disintermediation. You don't want to lose your broker because they can no longer make a profit. Anyhow, this is the last of our stories. I'm going to truncate it a little bit, but what I want to show is the answer to the question, and this is what we worked out conceptually in 2015, but in 2019, we actually tried to make our own algorithm to explain the answer to the question at the top. What if everyone in an urban area achieved maximum symbiosis? What could happen? What would happen? How much more, if there's less waste, then we can put in more tonnage into the landfill because there's a vacancy from the things that were saved. How much more wastewater treatment space could we save and not have to build so much infrastructure, which this is also in India, which has been a struggle sometimes. And so this is really an experiment. We said, let's look at every single commercial establishment in Mysore, India. Let's go to all the databases. Let's figure out what their sales are. Let's figure out how much they already might use for symbiosis and how much more there is. And it's that differential that we use to be able to say, well, now we're using 20% of old garments and we want to get up to 80%. We'll never get 100% of everything, but what if we took these ambitious guesses? And what this chart shows you is kind of fascinating. One of the conclusions of lots of very quantitative work is to say that what we see here are common materials: wood chips, paper, stone wool. These are in the top 5. And what we tried to calculate was how much of local industrial demand could be replaced within the city by its own byproducts. And the answer is, for these first early materials, for wood chips and paper, 100%. For stone wool, 100% if we were all doing the maximum recycling. So this is really our what we mean by industrial symbiosis potential, and how we think that once knowing these things, how effective it, even at the local level, returning and reusing materials can be. All right, I'm going to just talk about the last few categories. These are our contributions. I put in here the dynamics of industrial symbiosis. We've already talked about that. These dynamics such as self-organization and top-down government ownership and so forth. So what I just want to say briefly is that we think of the network, we think of these industrial symbiosis clusters as networks. In ecology, symbiosis is at least two organisms, right? But we say in order to be recognized as a symbiosis cluster, you need to have 3 materials and at least 2 companies, because what we really want to project is how this network can grow. So that's a contribution that we've made in many of our conferences. And also the most extraordinary thing lately has been our cataloging of about 800 peer-reviewed articles that we found in the literature that enabled us to catalog 89 industrial clusters in 21 countries. And what you see from the map is where they are. Most are in China. The second most are in Europe. The rest of the world, we don't have such emphasis on these clusters. But how interesting it is to be able to know that what these clusters are made out of and who and which companies exchange which materials with whom. And this is the database that we've been able to create from cataloging these 89 clusters. And it's been very useful for us to be able to have our own data, to share it with a lot of other scholars. And now we're looking at a whole nother partnership. But you can see that there are, on the left-hand side, who are the givers, who's giving a product to industries, who's taking the products that the givers are giving in these clusters. And we've been able to chart over 1,000 exchanges. This is the visualization of it that some of you recognize. These are all the industries on the outside. So there's food and beverage manufacturing and machinery and transportation. And if you could follow all those lines, you'd see exactly who was the giver and who was the taker, and could quantify that based on our database. Another contribution has been the fact that in addition to starting at Yale with the 2004 Industrial Symbiosis Research Symposium, now you see that we've done it every single year until COVID. And we've done it in Asia 4 or 5 times. We've gone to Europe and Australia and every continent that isn't Antarctica so that we could continue the flow of information with one another. Another contribution that is a little different comes from the let me go back here. This is a contribution, and now I want to look at our impact. So because of COVID, we were actually able to invite a lot of leaders to come to our industrial symbiosis seminar this past spring. And the tagline is value creation through data and resource sharing. And what you see is on the bottom line, well, these were our guests. And of course, I have a good network after all these years. You can see the Kallenberg people at the top. 3 of them came twice, and that was great because they have, from a research perspective, they have the longitudinal data available, and it's been great to have that. We had our colleague from Sweden who spoke about how the bioeconomy transition works with industrial symbiosis. This is a private company, International Synergies. Some of you may recognize my first doctoral student who did the work on social network theory and industrial symbiosis. The World Bank, the British Sugar, you've already heard, we got the Vice President of Sustainability to come, and that was exciting. And all the ones below the line are national programs. So for example, the United Kingdom was the first national industrial symbiosis program. Colombia now has a circular economy, a national program that has industrial symbiosis as its second recommendation. Israel has a national industrial symbiosis program. We'd never really interacted with them before, other than by phone and email. And so it was wonderful to have them. They had a different original way to do symbiosis. China's national program, Korea's national program, another one of my former doctoral students from Korea, Ju Young Park. So we keep in touch and we build the influence. And we feel that we've really started to bring people together. They call me, they say, how can I reach out to the other guy or to the other person who's still in the stage that we used to be in? And so it's been a very good collaboration. And we're really hoping that the 50th anniversary of Kalundborg, we can bring everybody together again and keep the information flowing. So finally, I want to say some of the ways we've been translating knowledge into impact. And this is an example because of our colleague at the World Bank. I asked him if he would provide us some data on industrial parks in Morocco, and he helped us a lot. He helped us look at 2 full business parks. One was automotively based and one was multi-industry based. And we put the class to work and created a paper that's not yet published called Data Limited Industrial Symbiosis, Developing Methodology and Application for Morocco. This is exciting for us. We created our own methods. We used our own database in step 2 to be able to facilitate understanding how the materials in Morocco could be reused on a much more thorough basis. And finally, my last slide talks about the impact that we've started to have by now having a partnership with the World Bank. We took the database that you saw, and we decided to join the World Bank's new platform, as did our colleagues from Korea. And now we've created a platform, or we're in the process of creating the platform for use by 350 industrial parks around the world. That's what the World Bank's hoping for. And my doctoral student, Koichi Kanaoka, has been advising on industrial symbiosis implementation, still in Morocco and also in Bangladesh. And most exciting of all, we've created a memorandum of understanding between the bank and the Center for Industrial Ecology. And both of our legal offices signed off. So it's really, it's really there. It's really coming, and we're very excited about this because of the impact it has all over the world, and especially in the global South. So a lot of the projects are in Pakistan and Argentina and so forth, and we're very excited with those opportunities. So that's it. That's what I have to say. These are the things that we've been pursuing in our research, and I'd love to answer any questions that there may be.
Marian, thank you very much. That's an enormously valuable overview you provided, and lens into the world of industrial ecology and industrial symbiosis in particular. We do have a couple of questions, and let me start with Quinn Zacharias, who's asking, how does the discipline of industrial ecology relate to the discipline, the discipline of industrial engineering relate to the discipline of industrial ecology? In other words, where does industrial ecology start and industrial engineering begin? Conversely, where does one of these end and where does the other start?
Well, that's a tough question for me because I don't know so much about industrial engineering, but I do have much admiration for industrial engineers who are really involved in the technical aspects more than we get to in industrial ecology. So I would say that if the industrial engineers get a 5,000-foot glimpse, we probably have a 25,000-foot glimpse, and where we start is with the bigger picture, tracking material and energy flows, often globally. And I think that industrial engineering is more place-based and is able to work in different arenas around the world on implementing the industrial engineering project.
Let me turn to a question from Kangning Wang, and it relates to the issue of fossil fuels. And frankly, I'm going to paraphrase in the interest of time. And it raises a concern about whether fossil fuel burning facilities are part of an industrial symbiosis structure. and whether the presence of those facilities doesn't make it difficult to maintain the effectiveness of the symbiosis on the one hand, or risk limiting the transition to renewable energy on the other.
So a lot of that important question will actually depend on where you are. You know, in China and India, we know there's still a lot of coal use. So industrial symbiosis tries to work with whatever there is and to reduce emissions and to improve the collective area. And so if they're using coal, there's not, you know, we can suggest other options, but that's not really the symbiosis part. The story on fossil fuels, though, is being told now. There was in Kalundborg, there was a coal-fired power plant for all these years, and the people in Denmark are fairly progressive, and they said, we don't want this anymore. And sure enough, Ørsted Energy, a very prominent company there, said, okay, we're going to close all our coal plants by 2025. We're just not going to do it anymore. And I could show you picture after picture of the new energy that's being developed in Kalundborg. A lot of it, it relates to biomass and the use of biomass. And it's been yet even more opportunities for the pharmaceutical company and the gypsum board company to get more byproducts that they've been able to use successfully. So that's a good story. I can't say all the stories are that good. But with the rise of solar and wind and the prominence and the cost of, you know, that since the cost has been dropping, we're prepared for whatever's there, and we'll try to use it and make it the best environmental performance there can be.
Marian, with 1 minute left, I want to get to a question from Michael Dove and give you 30 seconds to answer.
Okay.
But Michael is highlighting your example from India, where you said there was a 99.5% use of the residuals. Michael's asking, why India? What explains why this site is so much more successful than what you find elsewhere?
Great question. We've thought about it a lot, Michael. And what I want to say is that two things. One, we have noticed over time that the people in India are just care a little bit more about conservation and not throwing things away. Underneath that is the fact that there are a lot of poor people in India, and they really can't afford to not reuse their materials. But even the wealthier people don't like to throw things away, and we think that that's part of the culture, that it lets at least always be open to the reasons and that we can and should reuse materials. So it's not completely thorough an answer, but it's very important to recognize what can be done. And I didn't specify what companies were in that Indian cluster, but I mean, Nestle's is there, and they're taking their coffee grounds and their tea leaf, residues, and they're reusing all of them. And there are willing customers who can getting these at low cost or sometimes no cost. So these economic factors and these cultural factors roll together.
Marian, thank you very much for an enormously illuminating presentation, ending right on time. And I invite all of the virtual audience to join me in thanking you with a virtual applause. Thanks again.
And thanks for coming, everyone. I really appreciate it.